Any takers?
So with like how do I get a technical definition of declare type and object type? Like I know like declare type's the left side of the equals and object's the right, but like when it comes to like the technical definition of it, like how do I know which one's which?
Yeah, so let me pull up the slides because there's two terms for each. It's like declared type is static type is what is I think on the left, and then dynamic type is on the right. Um, in terms of the differentiating between the two, your static type should always be the name of an interface, and the reason that it's called static is because you can think of it like because it doesn't have an implementation of methods yet. So natural number, the interface doesn't have any implementations for any of the methods. It's kind of static, whereas natural number one or two is dynamic, and so it has actual implementations. But let me pull up the slide deck here, and we will talk about the actual names of them. Okay, I got it. Okay, so the declared type or static type is on the left here, always the name of an interface, uh, and then in this case it's natural number, and then the right side is where is it? The object type or the dynamic type. So the reason that it's called object type is because it's the actual object that you're creating. You're creating an object of natural number two. If you try to in Java declare an object of type natural number, it will say you can't because you physically can't make an object out of an interface. It'd be like trying to drive the blueprints of a car. Um, in terms of definition, that's as detailed as you're going to have to get, if that makes any sense. You're just going to have to know that object type or dynamic type is on the right. That's what's used to determine which implementation of the method to use. And then the left side, the static type, um, is simply just the name of the interface which you're implementing or you want to create an object based off of.
Okay, thank you.
Hmm.
I have a question.
Yeah.
So for the written response, like the coding ones, will there only be what two questions on regarding that, like two recursion problems?
Yes. So you will have two coding questions, I believe.
Mm-hmm.
So, yeah, two coding questions. And they will be they could be anything,
Cool.
but
Thank you.
typically they're geared towards recursion.
Okay, cool.
What else do we have?
Will we go over the stuff from this week, like JUnit testing and?
You will be asked like you might be asked like conceptual questions about JUnit testing. So things to
Okay.
do with like what is testing used for, what can testing be used to prove or disprove, that kind of stuff. But you're not going to be asked to um, like write your own test cases. You might be asked like what's the difference between like a boundary case versus a routine case versus um, a challenging case, but
Mm.
nothing too crazy.
Okay, cool. Thank you.
Hmm. Okay. I have been asked to go over there's two example recursive methods that were posted on the test bank. So I'm going to go over those now if people are okay with that. Um, and I actually have them posted up here. So let me just pull those up. Okay. share my screen. So the first one, an example of one would be this one here, if you can see it. Returns the number of digits of at code n. In this case, n is a natural number. So the parameter that's being passed in is n, the natural number whose digits to count, and then you want to return the number of digits in n. It ensures that the number of digits of n. Since n is not described as a replaces or a updates parameter mode, it means that we have to restore n at the end of the method code. So just keep that in mind. I will say for most of natural number recursive methods that you are asked to write in this class, they all do follow a very similar structure. And that structure, essentially, 99% of the cases, is your base case is going to be when n is 0. So you want to keep looping so that you go through every single digit within the natural number. And then at some point, you're going to have to look at whatever the last number is. So in this case, you do n divided by 10. And then afterwards, you have to restore it. So you do n dot multiply by 10. I would say these 3 lines of code will probably be included in any recursive method that you write that's contained within or that you're asked to write in this class based on natural number, just because there's not much else you can do with natural numbers that's creative, I guess. And the other pieces of the puzzle are we have to have a count. So that's what's actually storing the number of digits that are in n. And then obviously we're going to have to return that count at some point. And then really the only other piece of the puzzle is that in order to get the count, we want to return 1 plus whatever the recursive call of count of digits n is. And just as like a proof of concept of how this will work, if you pass in a natural number that's say 1, 2, 3, here's exactly what's going to happen. So count's going to be 0. And then we're going to say if n dot is 0, it's not, so we're going to go in here. Last num, in this case, is going to be equal to 3. At this point, n is just 12. And then we're going to say count equals 1 plus number of digits n. So now, in this case, n is 12. This is a separate recursive call, so count is 0 again. N is still not 0, it's just 12 in this case. So we set last num equal to n dot divide by 10, so that makes it 2. This becomes 1. And then we say count equals 1 plus whatever the recursive call of number of digits called on this version of n is. So we have another call to n. We say, and in this case, where this recursive call is 1, it's still not 0, so we set count 0. Last num is going to be equal to n dot divide by 10, so in this case, 0. That makes n 0. And then we're saying that count is going to be equal to 1 plus number of digits n. So we call it again. In this case, count is 0. In this case, n is 0, so we don't do anything here, and we just return count. So in this case, we go back up here. We're saying count is equal to 1 plus the number of digits n. Number of digits n was 0, so it's just 1. And then n dot multiply by 10, last num, so we do not add anything. Or yes, last num was 3, 2. This should have been 1 because we went from 1 to 0. So then afterwards, n dot multiply by 10, we add last num, so n becomes 1. This count variable gets passed up to here, in which case we say that count is equal to 1 plus number of digits n. In this case, count was returned as 1, so this becomes 2. We do n dot multiply by 10, add 2 back, and then we do the same thing where 1 plus the recursive call. So in this case, count will be 3, and then we restore n, and then that gets returned back to the user. That might have been a little too fast, so I can go through another example if people are still confused. Just let me know.
What happens if like the number you put in is 0?
Digits is 0. Good question. So, that's a good point, actually. So technically, the number of digits in 0 is still 1. So here's how you could modify that. You could just say if n dot is, or, int count equals 0. Trying to think. I think for this, Hmm. So maybe you set count as 1, then that is a good question.
Couldn't you also do like a separate if statement as well? Like if the natural number n is equal to 0?
Yeah, that's what I was thinking initially, but I'm worried that if n is 0, you're saying just set count equal to 1.
Yeah.
Um, but then when you get to the base case, count will be 0.
Oh, then I'll go back to the first one.
Yeah, and it'll count 4. Um, that's a good question. I will ponder that and get back to you. Could we just do count plus equals number of digits 1 instead of adding 1 to the recursive call? Count plus equals. You could do plus equals, but in that case, you would have to set count to be 1 at the beginning because otherwise your count is going to be off. Um, in terms of the whole if 0 thing, I will say because I'm grading it, if you get into an edge case like that, I actually don't even know how you would account for the fact um, that there is a 0-digit number, so I just would not take points off for that. So you don't have to worry about that. But I'll ask Bucci about it and see what he thinks because that's a good question. Okay, and then I'm going to copy down the other contract because I actually don't have it on here. Um, but it goes something like this. It is reporting the number of tag nodes in T with no children. And then your ensures clause is that the tag leaf count is equal to number of tag nodes in T with no children. So essentially, if you have a tree, how many tag nodes are contained within it that have no children? So say an integer method, private static int tag leaf count, XML tree T. And similar to the way that a lot of the natural number recursive methods follow a pattern, a lot of the XML tree methods follow a pattern as well. And what your base case is going to be is if n dot number of children or t dot number of children is greater than 0, then you have to recursively call the method on uh, all of its children. If a tag node does not have any children, then you do not have to count anything. So if t dot number of children is greater than 0, then you need to loop through all of the children and recursively call the method. So for equals 0, I is less than t dot number of children, I plus plus. And you recursively call tag leaf count. And we're going to have a count variable for this one as well. Count equals 0. So count would be plus equals tag leaf count. And then you have to call that on an XML tree. So you would call t.child of I. So that takes care of looping through. That will actually loop through the entire tree. And then you get into the question specific part of it, which is counting if it is a tag node that has no children. So second, for a number of children, would n.toString.length be advisable? I am not 100% sure how for a number of children how the length variable works for XML trees. I would say it's easier, way easier to just do number of children. Okay. So since the only types of nodes that can have children are tag nodes, uh, we can include a check to see if T is a tag, because otherwise it's not going to have children, so we don't need to count it. And then the only thing we have to do is check if it doesn't have any children, then that's the other part of our condition. So if it is a tag node and it has no children, then we just increase the count. So count plus plus. Oh, for natural number dot number, natural number of children method. You could use n dot toString dot length, um, but it would just be a lot easier to just use n dot is zero, because that's what you would be testing for the base case. Okay. Any questions on this one? Okay. Then any more general questions about the midterm? Oh, somebody asked for another example of the number of digits recursive method, so I can go through that as well. So we can just go through 1, 2, 3, 4. If you are, I guess, writing recursive methods, this is the way that I would test your recursive method is just separate out the calls into different recursive calls. So this would be one recursive call, this would be two, and then this would be three. So as you initially pass it in, we have that, in this case, we're going to go back to the original, which was count equals 0. So count is going to be equal to 0 for all of them. And I'll actually take it a little bit slower this time because I kind of sped through it last time. But so count is equal to 0. We're saying last num should be n dot divide by 10. So last num in this case is 4. In this case, n is 3. So 1, 2, 3. And then we're saying that count should be equal to 1 plus, actually, I need to go back to the old one, 1 plus number of digits n. So count should be equal to the result of calling 1 plus number of digits on n, which is 123. So that's where this second recursive call comes in. So now we're calling it on a natural number of 123. Count in this case is going to be equal to same thing, but we'll get back to that. We call n dot divide by 10. So n becomes 12. Last num becomes 3. And then we're saying count should be equal to 1 plus number of digits, where we're calling number of digits on a natural number, which is just 12. So we go into another recursive call, which number equals 12. We call n dot divide by 10. So n becomes 1, last num becomes 2. And then we're saying count should be the result of calling 1 plus number of digits on a natural number, which is just 1. N is 1. Last num, I'll keep it consistent. Count is 0. Last num is going to be equal to 1, which makes this 0. Now we're saying count should be equal to 1 plus number of digits passing in 0. Then finally, we have one last recursive call, which is n equals 0. And in this case, n is 0, so it will just return count, which is 0. So the resulting call of number of digits called on 0 is 0. So count in this case is going to be 1. And then we multiply by 10 and add 1. That's that last part here. N dot multiply by 10, add last num. Now we're saying, hey, what is the result of calling number of digits on a digit of 1? Well, we just calculated that. It's down here. It's 1. So this becomes 1 plus 1, or 2. Then we call n dot multiply by 10, and then add last number onto n. And then up here, we say, what is the result of calling number of digits on a natural number called 12? Well, we just calculated it. It's 2. This becomes 3. Then you do the multiply by 10, add the last num. And then finally, we say, what is the result of calling number of digits on a natural number that is 1, 2, 3? Well, we just calculated it, and it's 3. So this becomes 4. We set last num, add it back to n, and then that's our final answer. So n gets restored, and then the count is correct. Okay, other questions people have? Will there be a question about tracing tables? I can't answer that, but I will give you a lesson in history, which is that I have taken this class, and then I have TA'd for it, and then I have TA'd for it again, and then I've taught it, and now I'm teaching it for a 5th time, and I have never yet seen an exam that has not had a tracing table on it. So based on how much you value statistics and how much you value historical precedents, I will not answer the question of whether or not there will be a tracing table. I will simply say that out of the 4 times that I've seen midterm 2 previously, and in, I guess, the test bank as well, there has been a tracing table on midterm 2. So take with that what you will.
Will there be like short answer questions like from midterm 1?
There will be questions where you have to provide answers, and they may be like actual words instead of code. Yes, there will be stuff like that, where it's not just answering questions like fill in the blank or multiple choice, and it's also not coding. So
Okay.
sorry, that's the most I can give without being
Yeah,
too overly. I like my job. I'd rather not get fired. So
it's fine. Thank you.
okay, what other questions? If not, I will simply go through the schedule and I will look at what kinds of things that I think are important. Speaking of which, oh, will there be another vocab matching question? I cannot confirm or deny another vocab matching question, unfortunately. I actually haven't looked at the exam since I approved it. Actually, I can probably tell you for some. Just check. Um, there is not a matching question, unfortunately. I don't think. Wait, let me double check if I'm not lying to you. Yes, no matching question. There is actually I can probably just tell you. It's multiple choice, and then it's some short answer. There's a true false section. There's some coding questions, and then there is some more short answer. Yeah. So coding, true, false, multiple choice. Coding, multiple choice, true, false. Coding, true, false, multiple choice, short answer. Sorry, it's late. Okay, other questions? All right, if not, I will go over something that I think is important that a lot of people always get confused about, which is parameter passing with methods. Because I tell people, and I try to say draw pictures, but people never do. So I'm going to show you what that looks like with a sample question based on one that somebody brought to me in class, which is say you are passing or you have a method called foo, which takes in, I don't know, a natural number, and and let's say it takes in an uh, like int a, and then just for fun, let's say it takes in a Boolean b, and here's what it does with that. We say n1 equals new natural number, or yes, new natural number 1L, or I guess it would be, yeah, new natural number 1L, we'll just say that. We're going to use the value of a to make a new natural number. And then if b, so if b is true, we're going to say n1 dot increment. And that's it. That's all that's going to happen. So this is our fake sample method that we have over here. And then I'm just going to come up with a random question. I'm going to say, what is the resulting values for N1, A, and B for the following 2 method calls? So let's have one where we call foo on a natural number, which is just, or let's make a natural number. So natural number, let's say natural number like C. It's new natural number 1L, and we'll call this like 42. and then we'll have natural number D, natural number 2, 1L, like 42. Not the same thing. We'll do like 20. And then we'll say that we have A, which is E equals 5, and then int F equals 9, and then Boolean. And then we can just pass true and false as Boolean literals. Okay, so let's say we pass in C, E, and then false. And then we pass in D, F, and true. What are going to be the resulting values of C, E, D, and F after these method calls? So the first thing that I'm going to do, just to keep track of things, is I'm going to draw pictures, like I said we should be doing. But we have C, which all reference types have this little triangle thing going about them. So C is going to be a natural number, which has the value of 42. So we can put that there. We have D, which is a triangle, and that points to a natural number of value 20. And then we have E. Primitive types always are stored directly in the memory. So that's 5. And then F, which is 9 here. Okay, so this first method call, let's draw it out over here. We're passing in C and E. We're saying that it's false. So what happens is we create N1, which is a parameter, and we're saying that that links to C. So this will point here. And then we have A, which is a pass by value parameter. So that's just going to get whatever the value of A is, or whatever the value of E is copied. So it's 5. And then we have our Boolean B, which is just false. So I'm just going to abbreviate that as a big F. Okay. So then we're saying N1 equals new natural number 1. That should be 1L of whatever the value of A is. So this is like the aha moment. If you're falling asleep, pay attention now. What we do here is we take the reference that N1 points towards, which is this object value of 42, and we set it equal to its own natural number, which in this case is 5. Common misconception, it does not change C's pointer towards this object value of 42. It's saying that N1 should be a new natural number. This argument should be a new natural number of value 5. And then B is false, so we don't increment it. And then the method returns. And so after everything has been done, even though we've modified natural number N1 and it's passed by reference, because we said it was a new natural number, it's going to update the parameter as opposed to the argument. Cool. And so that's that first method call. Nothing gets updated, so the values afterwards would just be 42.5. And actually, the same thing's going to happen in the second example. That's actually not interesting at all. So what I'm going to do is I'm going to change it a bit. Let's say that instead of... Actually, wait, this is way more interesting of an example. Give me a second. As soon as I find the rectangle. Oh, that's not it. There's definitely a way to... Okay, we're just going to block out the... Oh, that's not it at all. Well, that's not it at all either. How do I fill it? Don't worry, we're getting there. I have a degree. Oh, look at that. Okay. So, if B, we are going to say N1 equals new natural number 1L of the value A. Else, we're simply going to say N1 dot increment. Oh, this is a way better question. This is a question I would put on a midterm because it's evil. It's devious. Okay. So let's go through the example again. Only this time different. And if I can get my pen back. Okay. So we make N1. I changed my text color. Okay. So, oh gosh, I made my pen way too big. Oh my God, now it's too small. Okay. We're back. N1 points towards this object value 42. A passed by value. So the value E gets transferred into that, and then Boolean B is just false. So we're just going to reference that as F. So if B not true, so what else are we going to do? We're going to call n1.increment. n1.increment is going to mutably change the object value wherever n1 is pointing. So afterwards, the value of this is going to be 43 because we're actually updating the object value of n1. We are not changing the reference value of n1 to be something new, so pointing it towards something different. We are changing the object value, which gets pointed towards by C as well. And so that's all that method does. So these guys all get deleted. I'm going to keep the pictures there, though, just for next time. And afterwards, the value of C is increased from 42 to 43. Okay. Now we can go to the second example, which is now n1 is pointing towards, what is it? No, this thing. D, which is 20. A gets copied in as F, which is 9. And then B is true. So since B is true, n1 is going to equal a new natural number. And this is the example that we just saw, where now n1 is pointing towards a new natural number of value 9. And then after the method call is completed, since we don't keep around variables that long, these guys all get deleted. So a lot of people tend to see that natural numbers are getting passed in and assume that the value afterwards will be changed because it is a pass by reference, but that is not always the case. A general rule of thumb is any time that you're calling an instance method on a natural number or another mutable reference type, it's going to change the reference value or it's going to change the object value of that natural number. And so it will get updated outside the scope of the method. But if you ever see something like this, where you're setting the reference value, n1, equal to something new or something different or another natural number, that does not impact the argument that it was passed into. So that's a fun example. Well, maybe not fun, but I think it's interesting. Okay. Other questions people have? What are all the immutable types that I should know? I would say that really the only important one that matters is XML tree. So knowing that XML tree cannot be changed. There's a very good graph somewhere. Let me find it. I think it's when we talk about mutable versus immutable types, but it has a list of pretty much everything. Give me 1 second. Where would it be? Maybe in the concepts. Actually, it would be in the references slide. Ah, here it is. Let me reshare my screen. Okay, this is the graph that I'm referencing. So, oh wait, it's probably the graph at the end, which actually splits them into mutable versus immutable types. That is more interesting. Here we go. Okay. So you have your primitive types, you have your immutable reference types, and then you have your mutable types. Strings in this case are a bit of a weird misnomer because while they are an immutable reference type, obviously you can do things to change the value of a string. Like, let me reshare. Oh, what's going on here? Okay, let me erase all this. Like obviously, if you have a string like this, string str equals hello, and then you say string plus equals like Stephen here. Like this is, I'm like 100% certain, like legal Java code. It might get mad at you because usually it likes to use the .concat method. But technically you can do this, which goes against what is a immutable reference type. But the way that it works in Java's memory is that it makes an entirely new string object and then repoints the reference back to the new string object that's created. I think you get that into that in software too. You don't need to know it for this class. For the purposes of this class, you should know that strings are an immutable reference type. Um, yeah, but you can reason about them as if they were a mutable reference type because Java likes strings. It's built-in type. Okay. What would you say is the trickiest or most commonly missed part of midterm 2 in the past? Actually, I can tell you exactly what it was. Not exactly what it was, but I can point you in the correct direction of what it was because I keep statistics on what the most missed questions are on the midterms. So let me go to that, remember which question it was, and then let you know. There was a question which 20% of people got right. That is concerning. Let me remember which one it was. Give me a second. Okay. Um, so again, the biggest conception that people have or misconception is passing parameters into sorry, I'm probably not loud. Filing cabinet. Okay. The biggest misconception that people have, the biggest thing people trip up on is passing parameters and basically the example that I just ran through. And the reason that that is because people refuse to draw pictures to work through their solutions. So I would say that's a huge thing. Um, Another one is uh, the result of calling methods. So knowing what gets called or what gets returned from certain methods. Like the natural number divide method, I believe, returns the remainder as an integer. Let me double check. See, even I'm confused on that. Natural number OSU CSE uh, component. Yeah, so add is a void method. Divide actually returns a remainder as a natural number. Um, Stuff like that is important to know, I will say. And then what you can do with the returning values of that. So if you try to compare, like if you try to do something like this, hold on, share my screen again. So if you try to do something like if n dot increment dot is 0, something like this, like I'm 99% sure. Actually, I have Eclipse open. I can double check. Will not compile. Then increment dot is 0. Yeah, so that will not compile. People think that because n dot increment is technically a natural number, you can use something like dot is 0 on it, but you can't because n dot increment is a void method, meaning it doesn't return anything. So you're trying to compare nothing to 0 essentially. Any other questions?
Can you go over homework 9, like one of the questions?
Problem 9 on which one?
Homework 9, like the last question, I think.
Yeah, I can pull it up. Let me do this. Okay, this one?
Yeah.
Okay, gotcha. Oh wait, did they provide examples for Oh, it's at the bottom. Sorry, I missed that. Okay, so this so I can actually write. So we have oh, okay, so again, just drawing pictures. We have a reference type, x equals new natural number 41. And then we have y, which is a new natural number of 78. Okay, and then we're calling, so this would be 41 and 78. Then we call swap x and y. So n1 in this case is going to point towards 41, and n2 is going to point towards 78. So in this case, n1 is 41, n2 is 78. Okay, so now we're saying natural number temp equals n1. So now we have a third reference running out of space, but this will be temp. And that will point towards this reference value here, which is n1. So now n1 and temp are both aliased to this 41 value, and then n2 is aliased towards 78, or point towards 78. Then we say n1 equals n2. So what we're doing here is we're taking this reference pointer n1, we're pointing towards n2 now. So now this is pointing towards 78. So now n1 and n2 are both aliased towards 78. Temp is still pointed towards 41. Now we're saying n2 equals temp. So n2 goes to whatever temp's pointing towards, which is 41. So now n1 is 78 again, and n2 and temp are both pointing towards 41. And that's the end of the method. But what happens is afterwards, all of these variables are deleted, and x and y are still pointing towards their original values. So nothing actually gets changed here. 41 and 78.
Thank you.
Okay, any other questions? If not, I will gift back 12 minutes of your night for more studying.
Can you go over parameter modes?
Yeah, let me pull up the
All right.
slide deck. I believe it's in the contract slide. Uh, right. So parameter modes are basically just a way to tell the user via the contract what could be happening or what will be happening to certain variables within the method. So there's 4 of them. The default one is restores mode, which essentially just means that nothing is going to happen to that variable. And the value that it has at the beginning of the method should be exactly the value it is at the end of the method. So if a natural number is passed in with a value of 123, afterwards it should be 123. Clears mode sets it back to an initial value. So if you have a natural number of 12, afterwards it's just going to be a value of 0. This one's also pretty cut and dry. Probably the most confusing one is replaces mode versus updates mode. And the main difference here is that a replaces mode parameter does not depend on the incoming value. So if you have a replaces mode parameter and it's like a natural number, for instance, its value might be updated, but it does not matter on the incoming value. So examples of this are copy from or transfer from. It does not matter what the original value of the natural number is because it's getting replaced. So yeah, copy from. You can contrast this to updates mode, which also says that the value might be changed. Only this time, the value does depend on the incoming value. So this is stuff like add, subtract, multiply, divide. Pretty much any natural number method that will modify the natural number, because depending on the natural number originally that you're adding to, it's going to be a different value depending on the value that you're adding to. All right. Any other questions?
Which slideshows should we look at? Like, when does like the midterm 2 material start and when does it end?
It starts here with course introduction and it ends here with JUnit. So all of
So we
it's
can
with
get tested on like midterm 1 material.
Well, yes, because everything is cumulative. So I can't just not ask you about primitive types because it was midterm 1 material. But most of it will be stuff that we have learned. Like it's heavily favored towards the stuff after the first midterm, if that makes any sense. Other questions? Okay, then I will hop out of here 8 minutes early, upload this video. Are there any Java best practices people forget, like two returns? Two returns is the biggest thing that people get points off. People always add two returns in um, their method calls. So as long as you don't do that, you're probably pretty good. And using break statements, I would say. Okay. I will see you guys tomorrow, 8 a.m. Be there. It's gonna be a good time. Good luck with studying, but make sure you don't stay up till like 3 a.m. That's just a dumb way to um, lose brain power. Okay. Good night. See you guys tomorrow.